Welcome back, Algebra. In this video, we're going to talk about the complex conjugate. So remember, we have some complex numbers, right? So I'll just give you a definition. We'll do some examples. So the complex conjugate of A plus BI is A minus BI. The complex conjugate of A minus BI is A plus BI. So let's take a look at what we have here. So we have the real part of our number A stays the same. In the number, the complex conjugate of A plus BI is A minus BI, so that stays the same. And we have the imaginary part, the BI, stays the same. The only thing that's changing here is the sign. Positive is becoming negative. Negative is becoming positive. Let me show you some examples, and I think that'll help us the most. So here's some examples. So here's a number on the left and its conjugate on the right. So if I have 2 plus 7i, the conjugate is 2 subtract 7i. If I have 48 minus 3i, then the conjugate is 48 plus 3i. If I have 1/2 c plus di, the conjugate is 1/2 c minus di. Notice all I'm doing is I'm just going through and I'm changing the positive to a negative, leaving everything else the same. Negative to a positive, leaving everything else the same. Positive to a negative, leaving everything else the same. And that's it. That's all it takes to be a complex conjugate. So we need complex conjugates for a few things. The first thing we're really going to use it for is division of complex numbers, which I'll talk about in a separate video. But I do want to show you something interesting about the complex conjugate. So here is an interesting fact about the complex conjugate. Let's suppose I multiply them together. I have a complex number, A plus BI, and remember here, A is just some real number like 2, 12, 7, whatever. And B is just some number. And then we have our cool imaginary I there. That's it. So I'm going to take that number and I'm going to multiply by its complex conjugate. So I'm just changing the sign. I'm going to do this as I prefer to in a multiplication table. So here I have A and then a positive BI. Here I have A and then negative BI. And I'm multiplying. And we'll see what happens. So A times A gives me A squared. And I have A times BI. And that gives me ABI. And then I'll take negative BI and A. And that gives me negative ABI. And then I'll take, last but not least, negative BI and positive BI. And that's going to give me negative B squared, I squared. Let me take this out of the multiplication table, and notice I have these like terms here. I have negative ABI and positive ABI. So those add up to be 0. So they cancel. And I'm left with a squared minus b squared I squared. Now don't forget this I squared is equal to negative 1. So then this becomes a squared minus b squared times negative 1. And that gives me a squared plus b squared. So check it out. No more i's. Look what happened here. I took a complex number, a plus bi, and I multiplied it by its conjugate, a minus bi, and I got a squared plus b squared. This I totally got eliminated. So keep that in mind when you're working with complex